Okay, here we go. I think it's on. I hope it's on. Good morning, anyone that happens to be awake. Monday edition of Lecture and Office Hours. It is Monday, April 13th, and it's 8 a.m. Hope everyone had an awesome Easter. I did. I got to cook lots of food, which I love, and tons of leftovers for the week. That's always awesome. Let's see. So I have a couple of announcements I want to go over, and then we have our pre-cal lecture for today. For those of you that are wondering, it's probably going to be this schedule for most days of the week until we have exams, and then things get shuffled around a little bit because both classes you're going to be having a test next week. So that does complicate the schedule a little bit, and in fact I'm going to talk about that soon. But I got lots of awesome feedback on the extra credit thing that we're doing. So let me switch over to that real quick and let me talk about it. Well, I guess the schedule first. So Monday, today, we're going to be doing the lecture for pre-cal. This is the last lecture you'll need before the next exam. So we're doing this lecture. It'll be due on Friday. And then after the weekend, I'm going to I'm going to post the test review, and then I'll have an office hours where I answer some questions, where I actually go over the test review with y'all, because we can't really do that in a normal lecture setting. And then probably exams for both classes will be on Wednesday next week. So just be ready for that. Dual credit, y'all's last lecture is tomorrow. And then the rest of the week is just office hours. Wednesdays, if you are participating in the extra credit, then checkpoint number 2 is due. So that's the next topic I want to talk about. So if you scroll on down to extra credit project, I went ahead and posted everything I want you to do for it. And this is just, small synopsis of everything that I had planned for the project. So if you click, those of you participating, you had to do group checkpoint number 1 already. The big thing with all of these is only one person from each group has to submit. So now that I went through all these, now that I have a list of all the groups and who's in each, you only need one person from each group. I tell you, whoops. No. There we go. Moving stuff around. I tell you exactly what I want in each of these. So just follow the descriptions, type it all out. Most of them are going to ask you to refer to some kind of online source. Just be sure to give me a hyperlink to whatever you looked up. And it's a pretty involved project. Each checkpoint takes about 4 or 5 days. And I know you might have stuff going on in other classes, but I mean, it's extra credit. So my logic here is that if you really want the extra credit on your average for the 6 weeks, then you will put in the time. And there's plenty enough work for a group of 3 to do. So if you are by yourself or you're working in a group of 2, you're going to be doing a little more than what a standard group will be doing. Okay, and then there's your assignment for today for pre-cal. Let's see. But yeah, just open office hours most of the week. Remember, not too many of you. I've had one person this entire time we've been doing online school. But if you need an individual conference and you need to do it outside of normal office hours, I'm available most of the day. I mean, unless I'm just trying to wrangle my kids. And you can email me and schedule. Some things are really hard to explain through text, through email. So if you want to set up a WebEx conference, or if you want me to get on stream to answer a few of your questions at the same time, something like that, just email me and let me know. I'm pretty flexible when it comes to my availability. So yeah, take advantage of that if you need it. Okay, let's jump straight into the lecture then. Alright, so pre-cal's lecture for today, double and half-angle identities. This is the last set of identities you need for either proving things or plugging numbers in. And yeah, you'll be ready for the test after this. I was debating on having the test this week, but it wouldn't fit the timeline I've been giving you the rest of it. I mean, I've been giving you a week to work on stuff this whole time. Also, they've been pretty adamant about don't give them too much stuff to do per week because they've got 8 classes worth of stuff to do. So that's what we'll do. Okay, so here is the formulas that you need. And again, remember, you're taking this test online. You don't have to memorize them or anything. So pre-AP, you get off the hook. Notice how cosine 2 theta has a bunch of different forms. And the only reason that happens is because remember how you have this one from before. Sine squared plus cosine squared equals 1. That's one of the very first ones we learned. If you just subtract sine squared over and sub in for cosine squared, or subtract cosine squared over and sub in for sine squared, you just combine like terms and it turns into the other forms of cosine 2 theta. So cosine 2 theta, it's not special in the sense that it has 3 different forms, but there's just easy algebra we can do to them. The other thing is these are all derived from the fact that 2 theta is just theta plus theta. And if you just do the sum and difference formulas we just learned last week, and then you plug in the same variable for both, like sine of y plus y or sine of x plus x, whatever, this is what you get. So great, we've got some formulas, let's use them. So your next homework assignment, you have split up into a couple of things. Use the given information to find sine 2 theta, cosine 2 theta, tangent 2 theta. So I call these general angle problems because they just give you some information about an angle. You have no idea exactly how big it is, but you do know what quadrant it's in. And then just try to label everything and try to plug in stuff into the formula. So they give you information about just theta. You want to find answers for 2 theta. So once we figure out the information on single theta, we'll need to use the formulas from the last slide to actually get the answers for 2 theta. So they're telling me I am between 180 and 270. So I am some angle in quadrant 3. I have no idea how big it is. It doesn't matter what the exact answer is. Somewhere in quadrant 3. So that means the reference angle would be right here. And there's my little triangle. And tangent is y divided by x. So the y coordinate would be 4 and the x coordinate would be 3. If you remember our little 4-quadrant thing, all students take calculus, cough cough. Then you remember that tangent is actually positive in quadrant 3 because the y coordinate and the x coordinate are both negative. So even though you don't see it in the problem statement, they have to be negative because you're in quadrant 3. It's just when you put them on top of each other, the negatives cancel. So do some Pythagorean theorem to find the r. And this happens to be a 3, 4, 5. So now we have everything labeled. Now let's find sine 2 theta, cosine 2 theta, tangent 2 theta. And if you look up your homework, it asks you only for one of these per problem. But we'll pull up the regular version. See, it just, like problem number 1, you just have to find cosine 2 theta. Problem number 2, you just have to find tangent 2 theta. So, just one at a time. We're going to do all 3 of them here just so you see an example of all 3 of them. So sine 2 theta, and then we're referring back to these formulas for these answers now. So this is 2 times sine times cosine. And now we just use that triangle to find sine and cosine. Sine would be opposite over hypotenuse. Cosine would be adjacent over hypotenuse, or y over r and x over r. So 2 sine is negative 4/5. Cosine is negative 3/5. And we just have to multiply all of those together. So if you just do the fractions, negative 4/5 times negative 3/5 is positive 12 over 25. And we just need to double that. So 24 over 25. And remember, the 2 only goes to the top. Remember, it's a fraction. It only multiplies the 12 on top. cosine 2 theta. You have all of these forms to use. I would recommend just using this one, usually, for these problems. That's not a star, whatever. Because when you do cosine squared minus sine squared, it's guaranteed to give you a common denominator because they both use hypotenuse on the bottom. If you use any of the other forms, you have to change the 1 into a common denominator before you add or subtract. So anyways, I will use this form. And pay attention to the order you're doing that because the negatives and the positives do matter. So cosine is negative 3/5 squared minus negative 4/5 squared. The square happens before the double negative happens. So you've got to do 9 over 25 minus positive 16 over 25. The square gets rid of the negative on the negative 4/5. So the one on the outside of the parentheses stays. Don't do a double negative here. So negative 7 over 25. Okay. And then finally tangent 2 theta. I'm going to end up writing under my face here. So this is a fraction 2 tangent over 1 minus tangent squared. And again, I'm referring to this last formula down there. And they tell me in the problem tangent is 4/3, so you should have gotten that already. So 2 times 4/3 over 1 minus 4/3 squared. Now I'm already out of room under my face here, but you just have to do a lot of work with combining the denominators. So let me move my face out of the way. There we go. I'll be up top for a bit. So this is actually 8/3 divided by 1 minus 16 over 9. You need a common denominator to subtract those in the denominator, so I'm going to change 1 into 9 over 9. So you have really 8/3 divided by negative 7/9. Keep flip change. 8/3 times negative 9/7. And the 9 and 3 simplify. So you've got negative 24 over 7. There you go. Oh, Kevin, I just saw your post. Do you want to see that work, or can we just plug into the calculator? For problems, let's see, like for problems like this where everything is a whole number, as long as you just show me the initial setup, where like, you know, you have here, let me use that laser pointer. So what work am I expecting to see if you are comfortable enough with this to do it on your own? I want to see just your initial setup where you plug stuff in. And then if everything's a whole number, you can just skip to the answer. Like for the tangent problem, I could have easily seen you going just straight from here directly to the answer because everything's a whole number. The reason I show you how to do all this in the notes is because, like, if you go back here to the triangle, if you have a square root involved at all, your calculator just won't handle it because it'll just pop it into an infinite decimal. So you want to be able to follow these steps to do it with a square root if you need. And you're going to see that a little bit in the homework. But to answer your question, if it's all whole numbers, fine. That's fine. Skip into the answer. Okay. All right. I'm going to move my face back. Whee! Okay. More formulas. So the reason why for these, and you might be wondering from the last week's lecture, why don't we have problems where we do unit circle stuff, right? Because we did that. You know, what is sine of 15 degrees? And you did 45 minus 30. The reason you can't do that for double angle formulas is because the whole reason you have these formulas would be like looking up something that's not on the unit circle. But if you take anything on the unit circle and double it, it has to be something else on the unit circle. Yeah. Like take 30. If you double it, it's 60. You can already just look that up. 90, double it, it's 180. Get it? 135 turns into 270. Anything on the unit circle doubled just becomes another thing on the unit circle. So doing problems that you have to double things doesn't make sense. So we just skip over those. So now we're going directly into half-angle formulas. Sine of theta over 2, cosine theta over 2. So you have plus or minus square root, and then you have a fraction. These are annoying because you end up plugging things into a square root, and then you have that plus minus thing to worry about. The plus minus thing, it doesn't mean that the answer is positive and negative. The answer, what these mean is that the answer could be positive or negative. And you have to pay attention to which quadrant you are in order to make that happen. So I'll talk about that when that comes up. But tangent theta over 2 is actually, ironically, the easier one to do in this section. Because if you look, you have the plus minus weird thing, but you can just use one of these other forms, and both of these forms are the easier ones to use. Okay. I hope you can hear my kids just playing and yelling outside my office door. It's very cute. They're trying very hard to get in. Okay. So let's do another general angle problem. Okay, use the given information to find the, so it's just like the problem we did, except we want new formulas, and then we're going to have to learn how to deal with that plus minus thing. So here we are given that we are in quadrant 4, and I forgot to mention this earlier, pre-AP these will just be given to you in radians instead of degrees, so be careful with that. We have another one where everything's a whole number. So Kevin, back to your question, you can skip over a lot of the work we're about to do. But let's draw our angle. We are in quadrant 4. There's my reference. Sine is y over r, or opposite over hypotenuse. So the opposite side's -5. The hypotenuse is 13. That makes this 12. All right, we've done Pythagorean theorem to death at this point. It's a positive 12, right? We're in quadrant 4. X coordinate's positive. And then, if you remember our handy-dandy little acronym, whichever version is stuck in your head. I don't think I can say the other one on Twitch. I mean, I'm sure I could, but... Okay. Ready? All right. Those of you following, those of you actually awake, the 3 of you that are awake right now. I'm just gonna randomly stop uploading to YouTube and then just let them freak out. No, I won't be that mean. Okay, first one, sine theta over 2. So the formula, if you look back, it has a plus minus in front of it. So when I set this up, 1 minus cosine theta over 2. And I've got some fraction math to do inside of the square root, right? But the key thing here, the new thing, the weird thing, is the plus minus in front. Since I am in quadrant 4, that's the information for just theta. My problem is theta over 2. Whatever my original mystery angle was, I'm supposed to be cutting it in half. So if I take any angle in quadrant 4 and I cut it in half, oh, I just wrote behind my email. Let me move it. All right, so if I take 270 and 360, which are my boundaries for quadrant 4, what happens when I cut those in half? So I get an angle that's between 135 and 180. Right. 135. What quadrant does that put me in? Between 135 and 180. That actually puts me in quadrant 2. So theta over 2, my half angle, is actually in quadrant 2. In quadrant 2, sine would have been positive. So I'm using the positive version of the formula. I'm going to toss out the negative for this problem. So now let's plug in cosine theta, which I read off my triangle, 12 over 13, divided by 2. You need a common denominator to make that work. So the 1 is going to change into a 13 over 13. So you've got 1 over 13 over 2. All right, keep flip change. You've got square root of 1 over 26, which is square root of 26 over 26. Do the whole rationalizing thing. And Kevin, you see why in this problem just plugging it in wouldn't have worked. And really for all of these, because you've got, or for sine and cosine at least, because you've got fractions, or you've got square roots involved in all of these. So, okay, cosine theta over 2. Very similar formula, except you just have a plus 1 plus cosine theta inside, see? So plus or minus 1 plus cosine theta over 2. Remember, we talked about the fact half angle would be in quadrant 2. In quadrant 2, cosine would have been negative, so we're going to stick a negative in front of this answer. So negative square root 1 plus 12 over 13 over 2. And now we're adding, so the numerator is going to be different. So square root of, the 1 changes into a 13 over 13. So 25 over 13. I can actually square root that 25, so I get negative 5 over square root of 26. So negative 5 square root of 26 over 26. And the key thing to understanding why that last step happens is because when you square root a fraction, you square root the top and bottom separately. Here, I'll write it up here. So for both of these scenarios that I just wrote out, you end up with a square root on the bottom of a fraction. That's why I'm having to change the way it looks. Okay. All right, and finally, tangent theta over 2. Ironically, this one's easier because you've got all 3 of these forms. You could do that first one and you could do something really similar to what we just did, but you can just use either of these other 2. They're both equally easy to use. So I'm going to use 1 minus cosine over sine. Again, that's just whole theta, so I'm just looking at the triangle for those numbers. So 1 minus 12 over 13 divided by negative 5 over 13. And then just some common denominator things to do here. And again, just like Kevin said earlier, just you could plug it into the calculator if you like, because everything's a whole number. But you end up with 1 over 13 times negative 13 over 5. 13's cancel. Your answer is negative 1/5. Okay, we just have one more problem to do. This is going to be towards the end of your homework. So here, with half angles, you actually can use your unit circle to look stuff up. So cosine of 112.5 degrees, obviously that's not on your, oh, we don't do trig charts. unit circle. Yeah. Okay, so cosine of 112.5 degrees. Now, obviously 112.5 is not on the unit circle, and we can't add or subtract anything on our unit circle to get a 0.5 somewhere, right? But now that we know half-angle identities, this is equivalent to saying cosine of 225 divided by 2, right? Half of 225 is 112.5. So since that's the case, I have a formula for half-angle cosine, plus or minus square root of 1 plus cosine theta, which is 225 in this case, divided by 2. And that's going back to this one right here, the second one. And guess what? I can look up cosine 225 on the unit circle. It's negative square root of 2 over 2. So I'm just going to do some work, plug that in, and simplify. It has a square root, so I can't just plug into the calculator, but do a little bit of algebra, and we simplify to get the answer. The annoying part of this problem is the plus minus in front. Which quadrant is this problem in? I'm in quadrant 2. That makes cosines negative. And again, we're using this right here. That thing I told you we would be using a lot whenever I taught it to you for the first time. Okay, so negative in front of my problem. Look up cosine 225 on the unit circle. So we have negative square root 1 plus negative square root of 2 over 2, all divided by 2. Don't worry about the square root on the outside yet, just focus on simplifying the inside. So I need a common denominator on top. I'm going to change the number 1 into 2 divided by 2. So I have negative square root 2 minus square root of 2 over 2, and that's still all over 2. So I've got divided by 2, which doesn't cancel. They're both in the denominator. So I've got 2 minus square root of 2 over 4. And then that thing I told you earlier about square rooting a fraction, you square root the top and square root the bottom. The top is a big mess. You can't do anything about it. But on the bottom, square root of 4 is 2. So when I write my final answer, the square root will only go on the top, and then the bottom square root of 4 is 2. And yes, you have a square root inside of a square root. So there's your final form of your answer. And that's how you do it. So that's your lecture for today. That should get you through the whole homework, and now you are done. You are ready for the next exam. So this homework is due Friday. I'm actually going to try something here. Hold on. I'll just do it live on camera. We're going to try to... Hold on. You know what I haven't tried before is, now that I'm on my home computer, I can just print this whole thing as a PDF. There we go. And then just print the whole slide. Alright, save as a PDF. Wait, what is the title of the lecture again? I want to make it look just the same. And I think if I just upload a PDF, it is going to actually... Alright, Kevin, I'm sorry. I'm not checking chat because no one's been awake this early all week. Can you tell us again about all students take calculus and how if one's positive, which one's negative? Yes, let me go back to the lecture. So right here, wherever I wrote it. So the reason we do all students take calculus is in quadrant 1, all trig functions are positive. So we say A for all. If you have an angle in quadrant 2, sine, and also theoretically cosecant because they're the same, but sine is the only trig function which makes cosine and tangent negative. So it's an acronym to tell you which of your functions are positive. So in quadrant 2, because sine is there, that means cosine and tangent are negative. In quadrant 3, since tangent is the only positive function, sine and cosine are negative. And in quadrant 4, since cosine is the only positive function, sine and tangent are negative. And that goes back to, whether x or y coordinates are negative or not. Sorry to get to your question late. All right. I am going to try this. And look, there's a PDF there. And I think now people always complain about not being able to see my writing because they don't actually do PowerPoint. Hey, look at that. It's nice being on my home computer. I completely forgot about doing this. So I might do that with all your old notes at some point this week. But you've got all my writing now. You don't have to do weird PowerPoint downloading things anymore. Okay, so that is the lecture for today. Are there any other questions? Again, I just want to stress that the extra credit, there's a lot of groups, which is good. I'm glad a lot of you are participating. I hope you have fun doing this. That's kind of one thing I want you to get out of it. But you do need to meet all the deadlines. So you have 6 total that you need to meet. If for those of you that have already signed up, like this was the official sign up, for those of you that signed up, you need to meet every deadline along the way. Yeah, Kevin, the PowerPoint, I left the PowerPoint of the blank version there too. So there's the blank PowerPoint, there's the PDF with my writing on it, and then I'm going to upload this video as well. That'll all be on there. Okay. But yeah, have fun with that extra credit. That's the most important thing. And then we'll do another big Zoom call. And I am going to record y'all. So we'll talk more about proper etiquette and actually putting on clothes to be on webcam later. Okay, I think that pretty much wraps it up, unless someone has questions. Your sum and differences, I'll grade and hand back to y'all sometime today or tomorrow. I took Friday off just because it was Good Friday. My family did a lot of stuff with our church online. It was kind of cool. And of course we had a giant meal yesterday. Okay, and again, let me stress, email me if you need me outside of this hour of office, office hour, not office hours. But I'm available. Just let me know. Okay, same time tomorrow.